This is where we're now, folks, with the door. I know it was a bit of a bird nest soon, but trust me, I've cut it down quite a bit. So I'll just explain 2 or 3 things on the board here. First we've got the Nano. This is the brains of the operation. This is the microcontroller for controlling the rack and pinion servos on these motors. Now there is 2 motors here now, or 2 doors here now. There will be 6 once it's fully tested and working. We have had 1 or 2 teething problems, to say the least. I've let it go the smoke on one of these servos by plugging the wrong way, i.e. putting negative to positive, and set fire to it. I've also smoked a Nano as well, the same why. The reason I reverse one of the polarities of the Nano. You can see when you start getting all these wires there, and it does get a bit confusing sometimes. I've also had to replace this servo here, the Hall sensor here, because it failed. So far that's it. I have got an opto isolator from one of my colleagues at Merck, Timothy. This gave quite a rough signal with the scope, so I went and done the capacitors on the board here. This is the optocoupler part here. What I've also got on the board here as well is this part here. It's a PC 9685. It's just a pulse width expander. Obviously we've got 6 points with 2 sensors each, and also got these LEDs here to show when the motors are running. It will get bogged down quite with the pins on the Nano, not enough of them, so I've had to use an expander to get all 6 doors working on the Nano. What it stayed to be the Nano? Well, maybe not. I did try the Pico, and that wasted 6 days. The problem with Pico is there's no library for the DCC. Even with the Nano there, I went through 2 libraries. I started off with 1 which was quite limited, and I actually found a new library for it. So that's that, folks. So when you open it up, doors open. The 2 can work at the same time. Don't get bogged down. When the codes are done there, you can only work 1 door at a time. Once you've got 2 engines going to the shed, it's not much use. You close the doors. You see the LEDs run here. Once the LEDs, the servos detach, it cuts the power off to them, so there's no delay with it. So I'll take across here and we'll just go through the code a little touch. Up here is where you include your libraries. This is the NMRA-DCC library. I've also got a wire, and I've got the add fruit for the pulse width modulation add-in there, folks. I've then got my configuration. DCC's got it pinned to, the number of doors is 2, and the number of accessories is 4, i.e. You've got 4 sensors, and the frequency is 50 megahertz. So timing consistency here as well. Movement timeout, 10,000 milliseconds, 10 seconds. It's a safety device built into it. If the sensors failed, the servo will just keep on triggering, and eventually get the smoke released from it. So it's a little safety device put in here. I put it at 10,000 milliseconds. I will cut it down to 8 seconds once I get refined. Also put a debounce into the sensors as well. The reason being is it's to get a sort of false trigger going into it. I put a bit of debugging as well, so the files can get debugged, so you can see what sensors working, what sensors not working, what motors working, etc. And then you get your structure, your DCC data. Going down through it there, we've got our globals there, then we've got our debugging as well with it. We've got a wee helper there for the pulse width modulation to the servo there, and then we've got a debounce sensor input as well. We've got the callback accessory command handler, and then we've got door processing loop, and we've got how you handle a delay in the servo detach, and the debounce limit for the switches as well. Got sensor report on that, we've got the target reached with it, we've got the start movement, and we've got the drive servo and timeout safety as well. This is all the debugging part of it, folks. You've got set up for the door there for independent servo calibrations. The reason being is we've got these servos are 360, so you have to find out where the stop position is and where the run position is, and you can also do the speed as well with that. All the way down there, folks, then we've got into the setup there. So we've got the serial print for the debugging there, and in here we've got the setup for the doors, independent calibration. We've got setup for the doors here, the independent doors. We've got 00, that's the address. We've got 12 is for the LED, 5 and 6 is for the sensor, and then 372, that's the holding position for the sensor, the servo. In other words, that's where you trigger that to 372, and it's at stop. Then you're open and you're close for both doors. Now you can see here, I've tweaked them a wee touch, so one can go a bit slower and one can go a bit faster. It depends on the servo you get, especially when you buy servos like these from China. They're never ever the same, so it gives a wee bit of calibration into your servos for speed and your hold position. And then you've got your DCC mapping, your institution, your code there. And the loop is a very short loop there, folks. It just looks for a code on the top here. So if I put in the serial monitor now, folks, I'll bring up a touch here. What I'm going to do, I'm going to open the doors first. And then we'll disconnect the Arduino from the power. So on start up, what it does, it checks where the doors are. If the doors are closed, it's happy. If the doors are open, as it is now there, I'll actually close the doors and then I'll tell you it's looking for a signal. So if I clear the serial monitor, plug it in. So it's gone through the initial check there, it's seen the doors are open, so it's going to close the doors. And that's it, it's now looking for a signal from the DCC system. So that's where we're at now, folks. I certainly was hoping to have these doors installed by now, because the model is in paint as we speak. It's just to do the mortar joints. So I was hoping to get this done today or this week. I'm working part-time now, so it has been a learning curve to say the least. Now, if I take you back to the computer now, we've got something called an AF. I've got something called an AF, that's called an Alistair Fitchie. He's my electronics guru, and I've asked him 2 or 3 times about what his thoughts on AI are. And he says, well, I'm quite clever, but lo and behold, he's not good at doing the programming. So I did use a little bit of help. I did use a little bit of help with the programming there. We used this chat GPT, which was a learning curve to say the least. I just started using the chat GPT for doing the coding there, folks. And you've got to learn this what you want. You've got to be very specific in telling it what you want these doors to do, what you want the DC packet to do. And it will do the code for you. It will do the code. And it gives you your wiring diagrams as well, etc. So I've used the chat GPT. Another one I've used as well is this Claude. And what I tend to do there, when I've got a program that does work or doesn't work, I take it from one chat to the next chat and I says, what do you think of this code? And one says this, one says that. So, for example, I'll go back to this part here there, and I'll ask it, can you clean, I spell clean right, sketch, or this sketch. I'll start looking at the sketch there and I'll start deciding there. And absolutely, here's a full clean for hybridisation, the DC motors there. So it's got to clean it up even more. What you've got to watch is when you start to clean it, it takes out the calibration for the servos, so you need to tell it to keep the calibration for the servos in it. So that's where we are tonight, folks, then. Hope you've enjoyed it. I said next time I'll hopefully get these doors inside the building so we can see them working properly. Please leave a comment, like, subscribe. Cheers.